Welcome back to Splatoon Project Inc. Part 7. So in this one, we're processing the 3D printed parts. So we are grinding them down to reduce the layer height, to grind the layer height smooth. And we're also soldering the PCB and doing a lot of the electronic work in this episode. So yeah, enjoy.
So I got the wireless breakout board hooked up. It supplies its own 3.3 volts, regulated 3.3 volts to this, so I could remove those regulators on top, which simplifies the PCB circuit in the long run. Hooked up the switch, the trigger, to replace this, which was a test anyways. So this is the trigger I'm gonna use. This is the reload trigger, reload button, and same thing over here. There's a wireless breakout board. Yeah, that removes this part right here. So again, simplifying the overall circuit. So yeah, you guys hear that? It works. And of course this works as well.
Basically, the past week or so, I've been converting this half of it, which goes to the ink tank, into an electrical diagram. So this is what it looks like with the batteries on the left, various regulators, pumps, MOSFETs, and that's the Arduino that it connects to, and the LEDs on the right. This section down here is actually a whole separate power system because I'm going to use two 14.8 batteries. There's going to be a separate 14.8 battery that powers the 24 UV LEDs that lights up the UV ink water. So I didn't want that system to drain power from just one source, so I'm basically going to have two 14.8 batteries in the system, and that's going to be its own separate thing on its own PCB. Here is the main ink tank PCB. So I basically scanned this so I could overlay them, and we lay out all the components that I need to solder onto the PCB. Once I get this soldered up, I'm gonna slowly transfer this over one by one so to make sure that soldering job is done correctly. One of the things that you really have to be careful about when you're transferring the electrical diagram into the PCB is that you have to account for all of the basically the nodes for the different powers and ground. I basically printed out the electrical diagram and I went through all of the nodes that I could see that were, for power, for ground, because there's three power sources for this system. There's 40.8, 12, 7.4, and 5. So there's actually four power systems, or four power potentials in the system, so it's good to keep them straight. And I basically have a checklist here. This is for the main system. For the UV light system, there's this many 12 volt pins and grounds, so that's why I wanted to separate them. That's for this section down here. That's for the UV light system, and this is for the main system for the ink tank. And I'm basically going to have two PCBs stacked up on top of each other in the ink tank when I build it up. So on to soldering. This is my impromptu soldering station. So we got the helping hand, got the magnifying glass, got the LED lights, and yeah, it was just a lot of soldering all the individual resistors and headers. And funny enough, this was actually a failure because one of the things shorted, so I had to do another PCB set after this, but I didn't record it, but we'll just assume that it worked. But yeah.
So this is the PCB, and I'm gonna do a test of plugging just the power in. So this is 40.8 volt battery, 7.4 volt battery. I plugged in the various linear regulators, the voltage regulators, and also a couple of, well, this is one of the MOSFETs, but I'm gonna plug the rest of them via this because they wouldn't fit otherwise. We'll see if there's any magic smoke after about 5 minutes or so. If there isn't, then I'll test voltages. So these are the various voltages that I should be expecting to see. And those are good, then I'll plug the rest of that into this. Alright, so power is hooked up, the switches are off, so here goes nothing. Same for this. So far everything looks okay. I don't smell anything. And just to double check that the switches are delivering power, so this is 14.8. This part right here is going to be for that battery. So right now it's off. It's basically 0. If I turn it on, right, okay, so we know that that's delivering power. Turn it off. Cool. This is the circuit for the 7.4, the power circuit. So right now it's off and we got power. So for sure we know that this basic switching circuit works. Okay, so I have those both hooked up. Switches are off, so I'm gonna turn it on now. So there should be power going into this. So this is live. So far there's no magic smoke, there's no smell coming off of this. The bottom looks okay, no smoke. Nothing, just smells like flux. I'll let that run for 5 minutes. And then if nothing happens, I'll go ahead and test the various outputs that I should be seeing coming from the circuit working with the linear voltage regulators. Okay, so 5 minutes later, everything is still cool to the touch. There's still no sign of magic smoke nor any smells. So I'd say this is more or less a stable PCB. Time to test the various, or time to check for the various voltages. And with that, we are officially off the breadboard. That is on its own PCB. This is the splatter gun. This is the ink tank. This was their home, but now their home is no more because now they are fully grown. Two separate systems right here, so there's no connection whatsoever. That noise that you're hearing when I'm pressing the trigger and the button is the water pumps turning on and off. I programmed them to actuate depending on what I'm pressing, so yeah. Yes! We're donezo. That is gonna go onto the tip of the splatter gun. That's the idle animation. And when I press the trigger, it'll go into a shooting animation. Fuck yeah.